Everything in this video exists. None of it is science fiction. None of it comes from conspiracy theories or imagination. These are real objects, real regions, and real phenomena that scientists have observed, measured, and confirmed. And yet, many of them shouldn't exist at all. According to our best models of physics, cosmology, and astronomy, some of these things violate the rules we thought governed the universe. Space is often described as empty, silent, and passive, but that picture is misleading. Space is active. It is dynamic. It is filled with forces, structures, and objects that behave in ways we do not fully understand. And the more closely we look, the more uncomfortable that realization becomes. One of the most unsettling discoveries of recent years didn't come from a distant galaxy or a violent explosion. It came quietly, passing through our own solar system, unnoticed at first. In 2017, astronomers detected an object moving through the inner solar system on a trajectory unlike anything seen before. It wasn't orbiting the sun. It wasn't bound by gravity in the way comets or asteroids are. It was simply passing through. Scientists named it Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. At first glance, it was assumed to be a comet. That would have made sense. Comets often come from the outer edges of solar systems. But Oumuamua didn't behave like a comet. It showed no visible tail, no cloud of gas or dust, yet as it moved away from the sun, it accelerated. Something was pushing it, but there was no visible force causing that push. No outgassing, no jets, no explanation that fit comfortably within known physics. Its shape was also strange. Based on how its brightness changed as it rotated, Oumuamua appeared to be extremely elongated, possibly 10 times longer than it was wide. Nothing like that had ever been observed before. Some scientists proposed it could be a fragment of a larger body. Others suggested exotic ice made of hydrogen or nitrogen. A few even speculated about artificial origins, not because that was likely, but because natural explanations struggled to fit all the data at once. And then, as suddenly as it appeared, Oumuamua was gone. We never got another chance to observe it up close. It left us with more questions than answers. It reminded us of something deeply unsettling. Objects from other star systems pass through ours, and we may barely notice them. And if one unusual object slipped by almost undetected, how many others have done the same? Not all strange things in space move quickly. Some remain fixed, massive, and inexplicably empty. There are regions of the universe where, according to our understanding of cosmic structure, matter should be present. Galaxies should cluster, stars should form. And yet, in some places, there is almost nothing. One of the most extreme examples is the Boat's Void. It is a vast region of space, roughly 330 million light-years across, containing very few galaxies. To put that into perspective, a region of that size should contain tens of thousands of galaxies. Instead, it contains only a handful. The Boat's Void was discovered in the 1980s, and it immediately posed a problem. The large-scale structure of the universe is often described as a cosmic web, with galaxies forming filaments and clusters surrounding vast, empty regions called voids. But the Boat's Void is too large, too empty, and too uniform. It challenges models of how matter clumped together after the Big Bang. According to simulations, Such an extreme void should be incredibly rare, if not impossible. And yet, there it is, an enormous absence carved into the universe. It's unsettling not because it's empty, but because it suggests that the forces shaping the universe might behave differently than we expect on the largest scales. While some regions lack matter, other objects contain far too much energy to exist in stable form. Stars, for example, are governed by a delicate balance between gravity pulling inward and nuclear fusion pushing outward. There are limits to how massive a star can be before gravity overwhelms it, causing it to collapse into a black hole. And yet, astronomers have observed stars that appear to exceed those limits. These stars are too massive, too luminous, and too long-lived according to current stellar models. They should have collapsed long ago, but they haven't. Some of these stars burn at temperatures and pressures that strain our understanding of nuclear fusion. Others seem to lose mass in ways that don't align with predictions. Each one forces astrophysicists to adjust parameters, revise assumptions, or admit uncertainty. These are not small discrepancies. They are signs that our equations are incomplete, that the universe allows stable configurations we do not yet know how to describe. As unsettling as massive stars are, planets can be even stranger. Not all planets orbit stars. In fact, astronomers now believe that there may be more planets drifting freely through the galaxy than there are stars. These are called rogue planets. They were likely formed in planetary systems and later ejected due to gravitational interactions. Once free, they wander through interstellar space in near total darkness. No sunlight, no warmth, just cold, endless night. Some of these rogue planets may be larger than Jupiter. Others may be Earth-sized. Without a star, their surfaces would be frozen, solid, but deep beneath their crusts, some may still retain internal heat. There is speculation that subsurface oceans could exist, kept liquid by radioactive decay or tidal forces. If so, then life might exist in places completely detached from stars. Life without sunlight. Life without a home system. The idea challenges our most basic assumptions about habitability, and if rogue planets are as common as current estimates suggest, then the galaxy is filled with dark worlds we will likely never see. Darkness itself plays a far larger role in the universe than light. When astronomers measure the rotation of galaxies, they find something deeply troubling. The visible matter isn't enough to hold galaxies together. According to Newtonian physics and even Einstein's relativity, galaxies should fly apart, and yet they don't. Something unseen is providing extra gravitational pull. This invisible substance is called dark matter. It does not emit light. It does not absorb light. It does not interact with normal matter in any detectable way except through gravity. And yet, it makes up approximately 85% of all matter in the universe. Without dark matter, galaxies would not form. Stars would not cluster. The large-scale structure of the cosmos would collapse. And still, we have never directly observed it. We don't know what it's made of. We don't know how it behaves beyond its gravitational effects. Entire experiments deep underground are dedicated to detecting even a single dark matter particle. So far, nothing definitive has been found. The universe, as we experience it, is built on something fundamentally invisible. And that fact alone should be unsettling. As strange as dark matter is, it's not the coldest or quietest thing we've encountered. Space is often described as freezing, but the coldest known temperatures in the universe have been created on Earth. in highly controlled laboratory conditions. Scientists have cooled atoms to fractions of a degree above absolute zero. At these temperatures, matter behaves in ways that defy intuition. Atoms slow to a near standstill. Quantum effects become visible on macroscopic scales. Particles begin to act as waves. Cause and effect blur. These experiments are not just technical achievements, they are windows into regimes of physics that rarely occur naturally. They show us that reality has layers, and that under extreme conditions, the rules we take for granted no longer apply. Even space itself can be bent, stretched, and distorted. Massive objects like stars and galaxies warp the fabric of spacetime, causing light to curve as it passes by. This effect, known as gravitational lensing, allows astronomers to see distant objects magnified or duplicated. Sometimes, the lensing reveals mass where nothing visible exists. Entire clusters of dark matter can be mapped solely by how they bend light. In some cases, the distortion is so strong that it creates rings, arcs, or ghostly duplicates of the same galaxy. It's a reminder that what we see is not always where things truly are. Space is not a passive stage. It is an active participant. And then there are black holes, regions where gravity becomes so intense that not even light can escape. Once considered purely theoretical, black holes are now known to exist at the centers of most galaxies. Some are millions or billions of times more massive than the Sun. They influence the motion of stars, the formation of galaxies, and the evolution of cosmic structures. And yet, their interiors remain completely inaccessible. Beyond the event horizon, our laws of physics break down. Time and space exchange roles. Singularities appear in equations, signaling that our models have reached their limits. We can describe the edges of black holes, but not their cores. They represent boundaries of knowledge, places where prediction ends. Perhaps the most unsettling realization of all is this: the universe is not hostile. It is indifferent. It does not care about observers, meaning, or comfort. The laws of physics operate without regard for intuition or expectation. Structures form and collapse. Matter assembles and disperses. Vast regions remain empty. Invisible forces dominate visible ones, and our understanding, while impressive, every discovery reveals not only new facts, but new gaps, new questions, new uncertainties. Space is not a puzzle waiting to be solved once and for all. It is an ongoing confrontation with the limits of human understanding. And the more we learn, the clearer it becomes that the universe is under no obligation to make sense to us.